Hi everyone, welcome to today's video. Today we will start building our decentralized app or DApp. A DApp will be a decentralized version of a Twitter or a LinkedIn poll where a user can go and vote on a question by selecting one of the options that we have provided. Except that this is going to be a decentralized app and unlike Twitter or LinkedIn, its code is going to be written on the Ethereum blockchain. So we will begin by start writing the smart contract for this app and let's get started. We will begin by going to remix.ethereum.org and we'll create a new contract. We will call it polling app.solve. Next, we define our solidity version. We will also add a comment declaring the SPDX license identifier as MIT. To understand why we need to add this comment, you can check out the link explaining that attached to the video description. Next, we define our contract class by typing contract poll back. We will define a variable of type string called question. This variable will store the question that we want to ask our dApp users. So let's set its value to what is the best blockchain in the world. Next, we will need a variable to store the options that our users can vote on. We will store these options in an array of strings. Declare a variable of type array. We add square brackets to the variable type and call it options. We will add our options as Ethereum, Bitcoin, Solana, and none of these. Now that we have our variables, we will define getter functions for them. We will create a function called getQuestion, which is going to be public view, and it returns a string from memory. This function is only going to return the value of the question variable. Let's try and run it now. We will go to the compiler and compile a contract. Now that it's successfully compiled, we can deploy it to JavaScript VM. On clicking the deploy button, we see an instance of the contract that we can interact with. Here we see our getter function called getQuestion. By clicking on it, we can see that it is returning the value of our variable question. In a similar manner, we're going to create another function called getOptions, which will also be public view and returns an array of string from memory. This function is also only going to return the options variable. I will again go compile my contract and before deploying, I will clear out the old instance, click on deploy, and now I can see both my getter functions here. So if I click on them, I can see that I am getting the value of my array, and by clicking on get question, I'm getting the value of the question. Now, before moving forward, we can simplify our code a bit. We can see that for every variable we define, we have to define a corresponding getter function. Solidity provides a better way of doing that. By simply adding a public keyword to my variable here, my getQuestion function becomes redundant. So I'm going to comment it out and let's look at the output. I will again go to my compiler, and I'll also click on auto compile so I don't have to do this step again and again, and I'll click on compile. Next, when I go to deploy this contract, I will see that I have this another getter function called question. And when I click on it, it gives me the value of my variable again. So we can see that by simply adding this public keyword, it behaves in a similar manner to the getter function that we had defined. Now I'm going to do a similar thing for our options variable, but I'm not going to comment out the getter function that we have defined. So I will simply add the public keyword to this function and I'll go and deploy it. Let me clear out the old instance and deploy again. Now here is a slight difference. The options getter provided by solidity is expecting an input, but my get options function is not. The reason is that while our getter function returns the entire array, the options getter provided by solidity only returns a specific value of the array. So we need to call it with the index as the parameter for the value we want to get. So if I call it with 0, I will get the 0th value of the options variable. Similarly, if I call it with 3, I will get the last value of the options variable. But if I click on get options, which was the getter that I defined, I will get the entire array. The final concept that we will cover is another variable type called mapping. As the name suggests, a mapping is used to map two values to each other. So we will define a mapping called vote count, and this is going to store the number of votes that each option receives. A mapping requires a key and a value. For our use, the key is going to be the index of the option in our options array, and the value is going to be the number of votes for that option. And like our previous variables, we will also have to define the type for each key and each value. We will define a type as uint mapping to a uint. Here, the first uint is going to refer to the index of the option, and the second uint is going to refer to the number of votes. So let me get rid of this function. I'm also going to use a constructor to define some values inside this mapping. The constructor is the function that is called when we deploy the contract. In the constructor, I am just going to copy paste some code and explain what it is. So in the constructor, what I'm doing is that I'm setting the value of each option's votes to 0. So for the vote count, for the 0th value of our options is 0. For the first value of our options is 1, 0. For the second value of our options is also 0. And for the third value is also 0. I'm also going to make this mapping public so that I get an automatic getter for this function. Let me deploy this and see what happens. So I'll delete the old instances and deploy again. As you can see, I get another getter for vote count. And if I pass 0 to it, I get the value 0. Similarly, if I pass 1 to it, I also get 0. If I were to go back to my constructor and say that, I want to start with 10 votes for Ethereum, 2 votes for Bitcoin, 3 votes for Solana, and 5 votes for none of the above, and deploy it, my getter will return different values. So for 1, it will now return. Oh, let me clear out the old instance, deploy again, and see what happens. So if I pass 1 to it, I get 2, which means that my first option has 2 votes. If I pass 0 to it, I get 10. An interesting feature of this mapping is that while we only have defined the values for 0, 1, 2, and 3, we can actually pass any integer to this function and it will return 0. So if I were to pass to it 10, it will give me 0. Or if I were to pass to it 4, it will still give me 0. Since we are anyways initializing our vote count mapping with all the values set to 0, we can actually comment all of this code out, because when we deploy the contract, we anyways want that the vote count for all our options be 0. If I were to comment this out, clear out the old instance, deploy again, I'll see that whatever value I pass, I will still get its count as 0. In conclusion, we have learned how to declare variables of type strings, mappings, and arrays in Solidity. We have seen how to create getter functions and use the getter functions provided by Solidity. Finally, we have seen how to use the constructor of a contract to set initial values to variables at the time when we deploy the contract. In subsequent videos, we will add more features to our D app and deep dive into more concepts in Solidity. Thank you.